So welcome to the lecture series of Applications of Partial Differentiation. In Applications of Partial Differentiation, we discussed so far how to find out Jacobian using partial differentiation. In previous lecture, how to check functional dependence of two variables or more than two variables. Now, the very important application we are going to discuss in this lecture is that to find out error or percentage error. To find out percentage error or error. So this is related to approximation. So we are going to discuss errors and approximations. Errors and approximation. See, in day-to-day life, we come across many errors. And if error is occurred, the final output is approximate. Final output is what? Approximate. That approximation is there due to error. For example, if I want to calculate the area of particular blackboard or particular rectangle, this is the rectangle, and area of this rectangle I am going to find. The actual area of this rectangle is I am taking 3, this I am taking 2. Okay, breadth and length of the rectangle 2, 3. Now, the area of this rectangle is what? 2 multiplied by 3 is 6. 6 units. Okay, meter, centimeter, square, whatever. Area. This is an actual area. But while measuring length and breadth of the rectangle, any board or any sheet, and if I commit a little mistake, means 3.1 is the breadth while measuring length and breadth, and 2.1. Okay, so 0.1 is the error occurred here in length, and 0.1 error occurred here while measuring breadth. Now, what is the area here? It is 2.1 multiplied by 3.1, whatever. Okay, is it 6.5? This is the area now. So in day-to-day language, so I am calling this as approximate area. Why? Because I have made the error while calculating length and breadth. So this is what? This is the approximate area. And the error in breadth, in short I am writing like this, error in breadth is 0.1 and error in length dl is 0.1. Is it? Now the actual error here, actual error while calculating length is dl, and this dl is what? It is actual error made while measuring length, and with respect to the actual length, this error I have committed, this error I have made, then this is what called the relative error. Relative error. dl, and I am using for length. dl, actual error, relative error, and if you multiply the relative error by 100, that is what called the percentage error. Percentage error. Here, I will be using this abbreviation for percentage error. Percentage. Now we are going to solve some problems on errors and approximation. Without wasting time, we are going to solve a problem on this topic, that is errors and approximation. Now, first one, find the percentage error. Here we are going to find a percentage error in the area of an ellipse when an error of 3% and 4%, error of 3% and 4% is made in measuring its major and minor axis. Okay, this is the question. Very simple. Now, we are going to solve this. Percentage error in the area I have to find. Percentage error in the area, if I denote A, I am using A for area. The percentage error in area we are going to find. This we have to find. Okay. And when an error of 3% and 4% is made in measuring major and minor axis. If I denote major axis by A, small a, then 100 dA by A is 3. This is the percentage error in major axis is 3, which is given. Percentage error in minor axis, if I call the length of minor axis is B, dB by B, it is 4. Is it? So this is given here. This thing is given. And we have to find percentage error in area. Okay, this we have to find, these two things are given. Now, in ellipse, this ellipse I am drawing. Okay, as everybody is aware that major and minor axis, this is major axis and minor axis. This one is minor axis. Here I am writing minor axis. Okay. Now this is A, this is B. Now, what we have to find here? Find percentage error in the area of ellipse. Area of ellipse. What is the area of ellipse? Area of ellipse is what? It is pi multiplied by A into B. Okay, A is major axis, B is minor axis. Okay. Now, this area of an ellipse I am denoting it by A, pi, A, and B. Is it? Now, percentage error in area of an ellipse I have to calculate. I have to take derivative. Here there are 3 variables. See, capital A, area is variable, small a, major axis length is variable, and small b, minor axis length is variable. There are 3 variables. Now I have to take derivative. If you take derivative of the product of 2 variables, pi is constant. It is 3.14 pi. 22 by 7 is pi. It is constant. There are 2 variables on the right hand side, 1 variable on the left hand side. And we have the product of 2. So you can take derivative directly, or if there is a product of the power function, the better to take log, because it will become very simple while taking derivative. That is the intention behind it by taking derivative. Now, what I am going to take? I am going to take log of both the sides. Taking log of both the sides. The log of left hand side is the log of right hand side.
You can write directly also. Here I am writing indirectly, but you can write directly also. Now log of first element plus log of second element plus log of third element by law of logarithm. Log of x into y into z is log of x plus log of y plus log of z. Now after taking log, you take derivative. Without taking log, you can take derivative. Okay, but for the sake of simplicity, I am taking log because we have the product of two variables on the right hand side. Now, differentiating this equation. Okay, we are taking derivative now. We are taking derivative. Now, derivative of log a is 1 by a and derivative of argument is d. Derivative of free constant is 0. Derivative of log of a is 1 by a. You don't forget that a and b are variable. Derivative of this is 1 by b. d. Is it? Now we want percentage error. Means 100 dA by a I want to multiply by 100. I am going to multiply by 100 here. If you multiply each term by 100, what will you get? 100 dA by A equals 100 dA by A plus 100 dB by B. It's simple. Simply multiply this equation by 100, that's all. Now this I want, this is the percentage error in area of an ellipse. This I want to find out. Now percentage error in A, in major axis is what? A is the major axis, is 3. This is 3. And percentage error in B, minor axis is 4. Therefore 7. The 100 dA by A is what? 7. Means percentage error in area of an ellipse is what? 7. Okay. You can write here percentage, no need to write it. Once you write percentage, there is no need to write percentage. Okay. What we have done here, while measuring the major and minor axis of an ellipse, and then in measurement 3% and 4% errors are made in major and minor axis respectively. So what will be the percentage error in area? That we have calculated. Now, very simple. Take log. No need to take log, but for the sake of simplicity, you can take log. Take derivative, multiply by 100 and get the answer. Very, very simple. The second sum. Same. Second. The question I am writing, in calculating the volume of right circular cone, okay. Now this sum is dealing with the volume of right circular cone. Right circular cone is what? The right circular cone is a cone whose base is circle. Its base is circle. That's what in this way you can remember. In short, in calculating the volume of right circular cone, the error of 2%, calculate the volume of 2% and 1% are made in measuring the height and radius, radius of base, height and radius of base respectively. What is the question? Find the percentage error. Find the percentage error in calculated volume. In calculated volume. Is it? Very simple. We are dealing with the right circular cone, and base of the right circular cone is a circle. And there are two variables: radius of the circle, radius of the base of right circular cone, and height of the right circular cone. And the base is what? Base is what? Circle. And there are two variables. This is height. Okay, this height of this. The line passing through the vertex of the cone and center of the circle is called axis. Okay. Just in short, you may remember the base is circle, therefore it is right circular cone in short. This height is h, and I am denoting the base. The radius of the base is r. Okay. Now we have to find out the percentage error in the volume of right circular cone. The volume of right circular cone. Okay. Once you draw the figure, no need to write what this is. H is the area, height, and r is radius. No need to write. Okay, this is very clear in undergraduate courses. Then no need to explain what is H, what is R, just like 12th standard. Volume is what? 1 by 3 pi r square h is the volume of right circular cone. This is the formula for the volume of right circular cone. Okay, volume of right circular cone. Is it? Now I am denoting it by V. V is equal to 1 by 3 or pi by 3 r square h. I want percentage error. We have three variables: volume, height, and radius of the base of right circular cone. And we have the product of two. So I am taking log of both the sides. Okay, taking log. Okay, if you take log of both the sides, for the sake of simplicity, I am taking log. Without log you can do it. So log of, I am writing directly, log of a into b into c is log of a plus log of b plus log of c, like that. I am writing directly. Log first element plus log second element plus log third element. Law of logarithm I used. Now log pi by 3, log of constant is constant as it is. And by law of logarithm, this 2 you can bring here, 2 log r, log h is as it is, and left hand side is log r. Okay, once you simplify it, then take derivative with respect to differentiating. Both the side. Okay. Now derivative of log v is 1 by v. And derivative of v, I have to write in the numerator, derivative of free constant is 0. R and h are variable. Derivative of log r is 1 by r dr. Derivative of log h is 1 by h, and derivative of argument is. Okay. I want percentage error. So don't wait for multiplying by 100. I am multiplying it by 100. 100 dB by V equal to 100 dr by r and 100 dh by h. Is it? Now the next step. 100 dB by V is a percentage error in V that we have to calculate. That I want 2 times 100 dr by r
is percentage error in radius of the base. What is the percentage error in radius of the base? It is 2. Okay, this is given. See, percentage error in radius of the base. Percentage error in radius of the base is what? 100 dr bar. This is given, which is 2. And percentage error in height is 1. Now, 100 dr by r is what? 2. 100 dh by h is 1. And it is coming to be 5. Okay. The 5 is what? It is a percentage error in volume. Okay. It is what? The percentage error in volume of right circular cone. In this way we have solved this problem. Very simple. Write out the formula. Take log. Differentiate it. Multiply by 100 because we are dealing with the percentage error, and percentage error is asked. And the percentage error of R and H given to you. Put down the value here and get the answer. Okay. Now third problem on the same topic. Third problem on the same topic. See, third one. Here, the period of simple pendulum with small oscillation is, okay, this period is given to you, 2 pi under root of L by G. Okay, this is given. In the last problem, volume we have written from our side, formula for volume of right circular cone, 1 by 3 pi r square h. Previous to that, the area of an ellipse we have written pi multiplied by a multiplied by b. But here the function is directly given. Okay, this period of the simple pendulum is given. Okay, this is given to you. This becomes more easy now. If t is calculated using L and G, here L and G are variable. I am not going into that what is L and what is G. In short, I have to tell you, I am going to tell you how to find percentage error, that's all. If t is calculated using L and G are 8.05 feet and 32.01 feet per second square respectively. Okay, I will be explaining once again respectively. Find the percentage error in T if the true values are 8 feet and 32 feet per second square respectively. Okay, same problem. Here, in previous sums, the percentage error was asked, but percentage error of other variable was given to you. Percentage error of H, percentage error of R, it was given to you. But here, the percentage error is asked. Okay, find the percentage error in T is asked. But percentage error of L and G variables are not given. Percentage error of L and G variables are not given. In other words, indirectly it is given to you. Directly it is not given. Now, we are going to solve it. See, the calculated value of L is what? Is 8.05. And there is an error of 0.05 and the error here 0.01. Okay. Now, the calculated value is what? L. What is given to you? L plus, this is a calculated value. Well, L plus DL is 8.05 and G plus DG is 32.01. And the true values are given to you. True values are 8 and 32. Okay, it is given to you. Okay, it is very clear that the DL is what? DL is 0.05. Putting value of N here and get it. Or from the observation directly, it is very clear that DL and DG are these values. No need to write units here. Once, okay, the last I will be writing unit if required. Is it? No. Now, we have been given a relation amongst T, L and G. Okay, this is a period of simple pendulum. It is given. Now, I want percentage error. So what I am going to do? I am going to take the log of both the sides, or you can write like this also for in order to reduce steps, L by G power 1 by 2. Taking log of both the sides. I am taking log. Without log you can proceed. Log of T is log of right hand side. Here log of A into B is log of A plus log of B, directly writing log of first element plus log of second element. Is it? Log of first element, log of second element. Now, log of 2 pi as it is. By law of logarithm, this 1 by 2 can be brought here. Log of L by G. 1 by 2 I brought here. Left hand side is as it is. Log of 2 pi plus 1 by 2. Log of A by B is log of A minus log of B by law of logarithm. Log of L by G is what? Log of L minus log of G by law of logarithm. Left hand side is log 2, it is very clear. Now, is after simplification, taking log or taking derivative or differentiating this. Okay, now differentiating this. Take derivative very carefully. Derivative of log t is 1 by t. Derivative of t is dt. Is it? Now, derivative of free constant is 0. 2 pi is constant. Log of 2 pi will be constant. 1 by 2 is multiplicative constant. That can be written outside. Derivative of log L. Derivative of log L. 1 by L dl. Plus derivative of log G is minus, this minus 1 by G dg. Now the percentage error is asked. Percentage error in T. So don't wait to multiply by 100. I am multiplying by 100. Multiply each term by 100. 1 by 2. I am multiplying here directly because 100 dl by L, 100 dg by G. Okay. Now 100 dl by L, it is a percentage error in L, percentage error in G. It is not given. It is not given. But you can find it out. You can find it out. Or you can find out percentage error by putting value of DL and L, DG and G, or here also itself you can directly write. Okay, no need to increase steps, 100 DL. DL is what? 0.05. L is what? 8. 100. DG is what? 0.01. And G is what? 32. Left hand side, percentage error in T, and that is what we want. And try to solve it. Use calculator and get the value. I think it is 0.297. It is what? It is a percentage error in T. T is a period of simple value. T is period of simple value. Okay. It's very simple, straightforward. Taking log, differentiate it. Directly percentage error are not given, but the value of DL and L are known to you. That I am putting directly, I am getting answer. Is it? This focal length which is given to you. Find the percentage error. Find the percentage error in focal length F. You have to find out percentage error in focal length. If U and V are both in error by P%. Okay. It's very simple problem. But here percentage value is not numeric, the percentage error by P. P may be anything, 1%, 2%, 3%, whatever. Quickly, I am going to read it. Focal length of the mirror is given by this formula. The focal length F is dependent on U and V variables. And we have to find out the percentage error in focal length F. Find if U and V are, the percentage error in U is P, percentage error in V is P. Okay. What to find? What is given? See, percentage error in U is given to you, which is P. Percentage error in V is also given to you, which is P. And what to find here? What to find? The percentage error in F we have to find. This we have to find. Is it? Now this is the given relation. What is given relation? 1 by V minus 1 by U equal to 2 by F. This is the given relation. We want percentage error in F, that's all. In previous sums, what we have done, we have taken the derivative log of both the sides for the sake of simplicity and then taken derivative. But here we cannot take log of this because it will not be resolved in a simple way, because log of A minus B cannot be resolved, We can have the log of A by B. If we have log of A by B, log of A minus log B, log of A into B, log of A plus log of B. But here log of A minus B, log of A plus B is there. It is not of any use. So I am not taking log, I am differentiating this directly. Okay. Here you don't forget that U, V are variables, F is variable. Derivative of 1 by B is minus 1 by V square and derivative of V in the numerator. Derivative of minus 1 by U is plus 1 by U square du and derivative of 1 by f is minus 1 by f square df, and 2 is there. Isn't it? Now we want percentage error in f. We want percentage error in f. Is it? So what I am going to do, just I am multiplying it by minus sign. Multiply by minus 1. Okay, just I am going to simplify it. See, in this way I am writing. I am multiplying by minus sign and b square I have split it in this way. I am multiplying by minus sign. In this way, multiply by minus sign. 1 by f square in this way I have split. Okay, v square is going to be u square f into f, multiplying by minus sign. This will be plus, this will be minus, and this will be plus, like that. Now multiply by 100. I am multiplying this by 100 because we want percentage error by v. 1 by v is already there. I am multiplying by 100. Multiply each term by 100. Multiply each term by 100. Is it? Now 2 by f as it is. This is as it is. Okay. Now 1 by v, percentage error in v is p. See, percentage error in u is also p. Now what I am going to do, p is I am taking common. 1 by v minus 1 by u. Right hand side as it is. Right hand side as it is. But 1 by v minus 1 by u is what? 2 by f. I am putting here 2 by f, its value. And right hand side 2 by f, 100 df by f. It's 2 by f. Okay, f is non-zero thing. Because focal length is, if f is 0, everything will get collapsed. The 2 by f gets cancelled. The p is equal to 100 df by f. And that is what we want. We want percentage error in f. The percentage error in f is what? This is what? Percentage error in focal length in f. That we have found. Okay, here we have not taken log, but it was not convenient. That's why without taking log, we solve this problem. Okay, thank you very much.